All right, okay. So let me take out the notes. Okay, this is trigonometry. Let's talk about some more stuff, and then tomorrow again we will talk about more questions, okay? We still have time. So let's talk about trigonometric identities, okay? Now you guys have just seen there was one question which we did not do, and that was about proving identities, right? It's very simple. In every identity, it could be a trigonometric identity, it could be a quadratic identity, it could be any identity. You have two sides, left side and right side. You can start off with the left side, you can make it look like the right side, you can do it other way around. Okay, so this is the idea behind identities. How exactly do we make one side look like the other one? This is what we need to talk about. Okay, so before that, let's talk about some helping identities, okay, that we would be considering. Okay, so this is basically some discussion about trigonometric identities, because these are also used for simplifying equations. Trigonometric identities. Okay. All right. Let me state a few. Now, what exactly is an identity? In O levels, when you guys were told that a squared minus b squared is equal to a plus b into a minus b, you guys did not make this look like this. No, you were told that it is an identity. Okay, so think about identities as formulas, as expansions, as equations that you already know, and you can certainly refer to that very identity. Just write it down and then you can simplify your equation. Okay, so there's no point in proving identities, but there is certainly a point in using identities to prove the identities you would get in exam. Okay, all right, so let's talk about some helping identities first that you guys need to remember. Okay, the first one is basically sine square theta plus cos square theta is equal to 1. Okay, this is the first one. Then the second one is, this would be used very less, but still for the sake of completeness, tan square theta plus 1 is equal to secant square theta. This would be used in A2 basically, but still it's good that you get used to it. And then it's 1 plus cot square theta equals secant square theta. This is the most important one, so I will just write it down as 1. This is the first one. And then the second most important one is tan theta is basically equal to sine theta divided by cos theta. And then for for A2, cot theta is basically equal to cos theta divided by sine theta. But for AS, just consider 1 and just consider 2. Okay, this one and this one, they are important, but for A2, not for you guys. Okay, now think about these two identities only, 1 and 2, and you guys would be able to simplify whatever identity you come across. Obviously you would have to spend some time initially to think about that logically, but let's see. Okay, so this is the first one and this is the second one. Okay, let me just switch to that past paper we were talking about, and let's see if we can just do this question now or not. Okay, all right. Okay, so I would certainly refer to the identities that we have just discussed, because they would be new for you guys. All right. Okay, it says prove the identity. Now this is the identity. Okay, now this is your left hand side and this is your right hand side. I've just told you guys it's completely up to you. You get to decide if you want to use the left hand side or right hand side, but obviously you need to decide that according to the number of marks. Now it's just a 2 mark question. You would have to do 3 to 4 steps at max, not more than that, right? It totally depends how many things you are just finishing off in one step. But this decision that if you should start off with the left side or right side depends upon you. But obviously you need to think about it logically first. Now, what do I get to see? I have two sides of the identity right in front of me, and I can clearly see that the left hand side is expanded and the right hand side is simplified. If I start off with the right hand side, I would have to expand that. So a better idea would be that I start off with the left hand side, I try simplifying it such a way that I finally end up getting 1 minus tan square theta. Okay, this is what the idea is. Okay, this is not that simple. Let's write down the helping identities we have. We know that sine square theta plus cos square theta is equal to 1, and we know that tan theta is equal to sine theta divided by cos theta. These are the two things, the two identities that we need to consider before talking about anything. Okay, let's directly start off with the left hand side. Left hand side is basically equal to 1 minus sine square theta, 1 minus 2 sine square theta divided by 1 minus sine square theta. I cannot cancel or do anything in the beginning. I need to use these identities, okay? And you guys would get to get used to this when in some time. Okay, instead of this one, I can write this thing. I can write sine square theta plus cos square theta. Sine square theta plus cos square theta minus 2 sine square theta divided by 1 minus sine square theta. I'm just playing with the numerator for now. Okay, just give me 2 more minutes, please. Okay, now sine square theta minus 2 sine square theta can be written as minus sine square theta. So cos square theta would come here directly, and I have just subtracted sine square and minus 2 sine square theta. This would give me minus sine square theta divided by, now for the numerator, I have 1 minus sine square theta. Can I not take the sine square theta on the other side and get 1 minus sine square theta? Because when I will do so, I would be left with cos square theta, right? So 1 minus sine square theta is basically cos square theta. Any confusion till this? We are done. We are almost done. Anything? Okay.
No.
Now at this point, I can write this fraction as cos square theta divided by cos square theta, and then minus sine square theta divided by cos square theta. These two would be cancelled. I would get 1. And for this, I know that sine by cos is tan theta. So sine square theta divided by cos square theta would basically be tan square theta. So I can write this thing as tan square theta. And finally, I am going to get 1 minus tan square theta, and this basically was my right hand side. So I started off with the left hand side. This was my own decision. This is what I had, and these were the helping identities. Just by trial, hit a trial method, I just tried using these helping identities, and finally I was able to make the left hand side look like the right hand side. So this is how we do these proofs. Okay, and honestly speaking, you can be prepared for everything except this question. For this question, you need to practice as many questions as you can, because you cannot keep anything in your mind. Like for trigonometric equations, we know the worst case scenarios, right? we have seen all the possibilities. It could be that the trigonometric equation has a zero. It could be this positive, negative. We know how exactly do we deal with that part. But if you have been asked to prove something, in order to do that in the exam pressure correctly, you need to practice as many questions as you can. And I would certainly share some practice questions, but not now. We will talk about some more questions about this together, and then tomorrow I will send you some homework questions just so you get to practice whatever we are studying. Okay, for now, just keep these helping identities in your mind, and I will just share this paper on group. Just have a look at it, just so if you have any confusions, anything, you can ask me directly in the beginning of tomorrow's class. Okay.
Miss, I
Yes.
didn't understand what you did after, like,
Mm-hmm.
cos squared theta minus sine squared theta
Mm-hmm.
divided by cos squared theta.
Okay, okay, I'll tell you. So basically, this is what we had. Okay, I know that if I have a minus b divided by a, I can write it as a by a minus b by a. Do you agree with this?
Yes, miss.
Okay, so similarly, I had cos squared theta. I've written cos squared theta divided by cos squared theta. I had this in the denominator minus sine squared theta divided by whatever I had in the denominator, that was cos squared theta. This was one fraction. This was one fraction. I've just split it one fraction into two fractions, just like this and this.
Okay, miss. Got it.
Yes, and then I was able to cancel cos square, and obviously tan theta is equal to sine by cos, so sine square by cos square would be equal to tan square theta. Okay, now this is something that you guys need to think about on your own. I don't want you to memorize a lot of stuff, right? We are good enough, we are mature enough to see if tan is sine by cos, tan square would be sine square by cos square. And that is it. For AS, you are only supposed to keep these two identities in your mind. That is it. Okay. Obviously, you would have to shuffle them, write it this way or the other way, but only these two would be used. The other identities are basically used in A2.